Hello everyone, I am Prashant Kumar, studying at Sri Venkateswara College of Engineering, Bangalore, Mathematical Foundations for Computing, Probability and Statistics. Today my topic is about probability distributions, understanding binomial, Poisson and normal distribution. Table of contents, binomial distribution, Poisson distribution, normal distribution, properties of distribution, calculating probabilities of binomial distribution, Poisson distribution, normal distribution. Introduction. Today we are going to explore the fascinating world of probability theory and its practical applications. Probability distributions are at the heart of this field and they help us understand how random events occur in nature and society. Probability distributions provide us with a mathematical framework for analyzing data, making predictions and testing hypotheses. Probability distributions are mathematical functions that describe the likelihood of different outcomes in random experiment. In this presentation, where we are going to learn about binomial, Poisson and normal distributions, understanding these distributions is crucial for various fields like statistics, finance and engineering. Firstly, binomial distribution. The binomial distribution models the number of success in fixed number of independent Bernoulli trials. It has two parameters, the number of trials and the probability of success. It is commonly used to analyze outcomes such as flipping a coin, rolling a dice, or measuring the success rate of a marketing campaign. The binomial distribution is probability distribution that describes the number of success in fixed number of independent trials, each with the same probability of success. It is characterized by two parameters, the number of trials and the probability of success in each trial. The binomial distribution is applicable in situations where there are only two possible outcomes such as flipping a coin or rolling a die. Poisson distribution. The Poisson distribution models the number of events occurring in fixed interval of time or space. It has one parameter, the average rate of occurrence, lambda. It is often used to analyze rare events like accidents, customer arrivals, or the number of emails received per day. The Poisson distribution assumes events occur independently and at a constant rate. The Poisson distribution is a probability distribution that is used to model events that occur randomly over time or space. It is named after French mathematician Simon Denis Poisson, who first introduced the concept in early 19th century. The Poisson distribution has several key characteristics. First, it assumes that events occur at the average rate at which events occur and constant over time or space. Normal distribution. The normal distribution, also known as the Gaussian distribution, is a continuous probability distribution characterized by its bell-shaped curve. It is widely used in statistics due to the central limit theorem. The normal distribution is defined by two parameters, the mean and the standard deviation. It is commonly encountered in fields like quality control, psychology, and finance. The normal distribution, also known as the Gaussian distribution, is continuous probability distribution that is widely used in statistics. It has a bell-shaped curve and symmetric around its mean. The mean, median, and mode of distribution are all equal, and the standard deviation determines the width of the curve. Many natural phenomena such as human height and IQ scores follow a normal distribution. Properties of distribution. All three distributions have distinct properties. The binomial distribution is discrete and symmetric for large n. The Poisson distribution is also discrete but often right skewed. The normal distribution is continuous, symmetric and follows the 68, 95 and 99.7 rule where approximately 68%, 95% and 99.7% of the data falls within 1, 2, 3 standard deviations from the mean respectively. Central limit theorem. The central limit theorem is one of the most important concepts in probability theory. It states that the sum or average of large number of independent and identically distributed random variables will tend towards a normal distribution regardless of the underlying distribution of the individual variables. This means that even if the original data does not follow a normal distribution, the sample mean will still be normally distributed. This is significant because the normal distribution has many useful properties and is widely used in statistical analysis. One example of the central limit theorem in action is in polling. When conducting a poll, it is often impractical to survey every member of a population. Instead, a sample is taken and the results are extrapolated to the entire population. Calculating probabilities with normal distribution. To calculate probabilities using normal distribution, we first need to standardize the distribution by converting it into a standard normal distribution with a mean of 0 and a standard deviation of 1. This is done by subtracting the mean from each data point and dividing the result by standard deviation. So the resulting value is known as the Z score. Calculating probabilities with Poisson distribution. To calculate probabilities using the Poisson distribution, we first need to understand its formula and the steps involved. The Poisson distribution is used to model the number of occurrences of an event in a fixed interval of time or space. Given a known rate of occurrence and assuming that the events are independent of each other, the formula for the Poisson distribution is P of x is equals to k, which is equals to e to the power of minus lambda into lambda to the power of k divided by k factorial, where lambda is the mean rate of occurrence and k is the number of occurrence we want to calculate the probability for. Calculating probabilities with binomial distribution. To calculate probabilities using the binomial distribution, we first need to understand what it is. The binomial distribution is probability distribution that describes the number of success in a fixed number of independent trials, where each trial has only two possible outcomes which we typically label as such or failure. For example, flipping a coin is a classic example of binomial trial. There are only two possible outcomes, head or tails, and each flip is independent of others. Conclusion. Probability distribution plays a crucial role in understanding and analyzing random phenomena. The binomial distribution models success or failure. The Poisson distribution models rare events, and the normal distribution models a wide range of natural phenomena. By understanding these distributions, we can make an informed decisions, perform statistical analysis, and gain insights into various fields of study and probability distributions, which are the fundamental concept in probability theory that allow us to model and analyze a wide range of real world phenomena. We have covered binomial, Poisson, and normal distributions as well as the central limit theorem and hypothesis testing. So, by understanding these concepts, we can make a more informed decisions in fields such as finance, engineering, and medicine. It is important to remember that probability distributions are not just theoretical constructs, they are practical applications that can impact our daily lives. Whether we are analyzing stock market trends or predicting disease outbreaks, probability distributions provide us with a powerful tool for understanding the world around us. Thank you.